Hello students, I'm Mr. Timosaus Nader. I'm the new math teacher. Today we are going to take lesson 1 in unit 1 under title Rational Number. Okay, first we should revise sets of number that we studied in the previous years. At first we take the counting number, which is denoted by the letter C. And C include 1, 2, 3, 4, 5, and so on. These sets of numbers is called C, counting number. Then we study N. N is the natural number, and it's included all the counting number and in addition the zero. Okay. So the natural number can be expressed as 0, 1, 2, 3, 4, 5, and so on. And finally, in the previous year, we take the Z. Z is a symbol of the integers, and it included from negative infinity and go on to 0, then go to the positive infinity. All these numbers inside is called integers, and the integers is divided into 3 groups: Z positive, 0, and Z negative. Z positive included from 1 to infinity, Z negative included from negative infinity until -1, and the 0. Okay, this year we will recognize a new set called rational number. Okay, at first we should know that the rational number is denoted by the letter Q. Q is a symbol of the rational number. If I ask you, what is the definition of the rational number? Okay, it will be the number that can be expressed in the form A over B, where A and B are integers and B not equal 0. The most important condition in the rational number is B not equal 0. Okay, and we should know that each of A and B are called the two terms of the rational number, A and A over B. Okay, and what if I ask you the mathematical definition of the rational number? It will be, open 2 brackets, x tends to x equal A over B, and A belongs to Z, B belongs to Z, and B not equal 0, and B not equal what? 0. This is the most important condition in the rational number. Based on the previous definition, we can say that all the decimal numbers are rational numbers. All the decimal numbers are rational number. Okay, for example, 2.5. 2.5 can be expressed as 25 over 10. 25 over 10, because the 10 makes the decimal point jump 1 step to the back. So the answer will be 2.5. And so on. 0.7 can be expressed as 7 over 10. Okay, the definition of the rational number is that number A over B and B not equal 0. Okay, A equal here 25 and B equal 10. And the most important condition that B not equal 0 and here is 10. Okay, second, all persons are rational number. All persons are rational number. For example, 15%. For 15%, I know that when I want to remove the percent, I divided the number by 100. So it will be a rational number. And for example, 73%, I can express it by 73 over 100. Okay, finally, all the integers are rational number. Okay, why, mister? For example, 3. Why it is a rational number? Because 3, I can express it by 3 over 1. Okay, a over b and b not equal 0, 1 not equal 0, so it will be rational number. And for example 2, negative 16. Negative 16 I can express it by what? Negative 16 over 1, rational number. Okay, a small note, I want you to know that each integer is a rational number with a denominator equal 1. Any rational number is any integer is a rational number with a denominator equal 1. Okay, what if I say a over b is a rational number, then b not equal 0? Okay, for example, if I give you this expression 7 over x minus 3 and I say it is a rational number, the rational number should be that the denominator not equal 0. So what is the value of x that not make the denominator equal 0? Bravo, x not equal 3, because when I put x equal 3, it will be 3 minus 3 equals 0. So 7 over 0 is not a rational a number. Okay, what if I ask you that the rational number a over b equals 0? Then a should be equal 0. A, the numerator, should be equal 0. For example, x minus 2 over x minus 3 is not a rational number. Or x minus 2 over x minus 3 equal 0. So I will say that the x should be equal 2. Equal what? Equal 2. So 2 minus 2 equals 0. 0 divided anything equal 0. Okay. What if I ask you what is I do to put the rational number in its simplest form? To make any rational number in the simplest form, you should divide each of its terms by the highest common factor, HCF, highest common factor between them. To put any rational number in simplest form, you should divide its terms by the both terms by the highest common factor. For example, put each of the following number in the simplest form. 8 over 12. What is the highest common factor between 8 and 12? Think about it. Okay, 4. So dividing the two terms by what? By 4. It will be 8 divided 4 give me 2, and 12 divided 4 give me 3. So the simplest form of 8 over 12 will be 2 over 3. Okay, another example. Negative 12 over 36. Negative 12 over 36. What is the highest common factor between them? Okay, 12. Okay, so 12 divided 12 equal 1. 36 divided 12 equals 3. So the answer will be negative 1 over 3. Okay. Small remark. We should know and revise that these two sample between the numbers is called absolute. And the absolute eat the negative sign. The absolute always eats the negative sign. So absolute and negative 6 will be 6. Absolute and negative 6 equal what? Equal 6. Second remark. When you give me a mixed fraction to 7 over 25 and I want to convert it to a fraction only, what I will do? I will multiply 2 multiply 25. 2 multiply 25 and add the 7. Add the numerator. يبقى 2 multiply 25 plus 7 over 25. The numerator will give me 57 and the denominator will give me 25. Okay. Some rational numbers couldn't be changed into decimals as the rational number 1 over 3. Try to use your calculator and put 1 over 3 and press equal. It will give me 0.3333333333 and the calculator is full of 3's. 0.333333. Okay. In math, we should make the numbers easy. So the mathematicians say we expressed that by 0.3 and I will put a dot over the 3. This dot means that the number is repeated for infinity numbers. Okay. So when I see any repeated number in the decimal, I will put the number and put a point over it. Okay, let's see an example. By using calculator, write each of the following rational numbers in the form of recurring decimal. 2 over 3, 2 over 11, 5, 71 over 33. By using calculator, we will get in 2 over 3 equal 0.666666666666 and so on. So I will put 2 over 3 equal 0.6 and put dot over the 6. Okay, the second example, 2 over 11. It will be 0.18. So I will put 2 dots over 1 and dot over 18 because 18 is a repeated number. And finally, this example, when I put it on the calculator, it will be 0.213. So the answer, it will be 5.213 and I will put 2 dots, not 3, 2 dots only. Dot on the first repeated number and dot over the third repeated number. So 5.213 and dot over 2 and dot over 3. Okay, I wish you understand this lesson and I want to see you later and goodbye in the next lesson.